All right, let's dig into something, well, literally under our feet. We're not just talking about roots and soil, we're talking about communication. Today, we're going to explore this really wild idea that fungi are actually talking to each other with electrical signals. And as you'll see, this beautiful concept has kicked off a huge scientific debate. So what if I told you there's a hidden language, a secret network humming away right under your feet in the forest? It sounds like science fiction, right? But this is a real, groundbreaking, and yeah, pretty controversial scientific theory that suggests fungi might be doing just that, talking.
So where does an idea, this out there, even come from? Well, it all starts with a hidden electrical language. Researchers basically started listening in on the electrical chatter of fungi, and what they heard? It was pretty incredible.
Okay, first things first, we need a super quick biology lesson. When you see a mushroom, you're just seeing the tip of the iceberg. The real magic, the main body of the fungus, is this huge underground network called mycelium. You can think of it like a biological internet, made of these countless tiny threads called hyphae that connects everything in the soil.
And this is where things get really interesting. Back in 2022, a computer scientist named Andrew Adamatsky did something pretty wild. He stuck tiny electrodes into the mycelium of 4 different kinds of fungi to listen. And he found that their electrical impulses weren't random at all. They came in these specific clusters, kind of like spikes on a heart monitor. Which led him to this huge question. What if these spikes aren't just noise? What if they're a language?
So he took these patterns and analyzed them as if they were a language. He grouped the spikes into words and just measured how long they were. And the results, they were honestly kind of mind-blowing. Check this out. The average fungal word was about 5.97 spikes long. That's bizarrely close to the average word length in human languages like English or Russian. I mean, that's a statistical match that's really hard to just brush off as a coincidence.
And it didn't stop there. The analysis suggested that these fungi could have a vocabulary of up to 50 different words. And just like us, they have a core vocabulary of maybe 15 to 20 words that they use all the time. It's almost like they have their own basic lingo for talking about, I don't know, good places to find food, or maybe warning about danger. We don't know, but it's fascinating to think about.
And it turns out, not all fungi are created equal when it comes to being chatty. One species in particular, the split-gill fungus, was basically the valedictorian of the group. It generated the most complex sentences, these long, intricate strings of spikes. It kind of suggests that, just like animals, different fungi might have totally different levels of, well, linguistic complexity.
Now, this whole idea of a secret fungal language, it fits perfectly into a much bigger and way more famous concept that you've probably already heard of. The Wood Wide Web.
Okay, so the Wood Wide Web, or the Common Mycorrhizal Network, if you want to get technical. This idea was really brought into the spotlight by the scientist Suzanne Simard. Her theory is that these huge mycelial networks aren't just doing their own thing. They actually connect to the roots of trees, creating this massive underground information and resource highway. It's like an arboreal postal service connecting the entire forest.
And the way it's supposed to work is just beautiful. The fungi act like miners, digging up crucial nutrients like nitrogen and delivering them to the trees. In return, the trees, through photosynthesis, create sugars, food basically, and send that down to the fungi. It's a classic win-win. But the story gets even more incredible. It suggests that giant old mother trees can use this network to send resources to struggling seedlings, and that dying trees can even pass on their life savings to their neighbors. It really paints this picture of the forest as one big, cooperative family.
I mean, it's an amazing story, right? This idea of cooperation and community in nature, it's so compelling it's been in documentaries, best-selling books, even hit movies. But, and this is a big but, the science behind it is actually locked in a pretty bitter fight.
Yeah, things got heated. In 2023, a group of scientists, led by Justine Karst, dropped a paper that basically sounded an alarm across the entire field. Their argument? That the popular story of the Wood Wide Web has gotten way, way ahead of the actual scientific evidence. They said that we've fallen in love with the story and are overinterpreting what the data really shows.
Now, to be super clear, they're not saying these networks don't exist. They absolutely do. The fight is over what they actually do. The rebuttal paper points out a few key things. First, we can't just assume these networks are in every forest. The field results are all over the place. Second, while nutrients do get transferred, it's not proven that this is what's making seedlings survive. There could be other explanations. In that biggest, most heartwarming claim, that mother trees preferentially help their own kids,
They say there is literally no peer-reviewed field evidence that proves that.
So, this brings us to the really big question here. Hype versus hyphae. How did this one idea capture the public's imagination so powerfully when the scientists themselves are still arguing about it? How did the hype get so far ahead of the hyphae?
Well, the researchers who wrote the rebuttal point to something called positive citation bias. It's a known issue in science. Basically, a study that finds something exciting and positive, like trees help each other, gets talked about and cited in other papers way more than a study that finds, well, nothing, or even a negative result. It creates this echo chamber where the positive evidence seems way stronger than it is. And get this, they found that the number of unsupported claims in the literature has actually doubled in the last 25 years.
And this chart really drives the point home. If you only got your info from pop culture, you'd think it was a slam dunk. All the science points to cooperation. But look at the actual research findings. It's messy. A huge chunk of studies found a neutral effect, or no effect at all. Some even found evidence of competition, not cooperation. The reality is just so much more complicated than the neat little story we've been told.
This quote from Sophie Yeoh in The Guardian just nails it. The speed at which the idea had spread through the public realm had outpaced the science underpinning the idea itself. It's a classic case of a metaphor becoming more powerful than the reality. The Wood Wide Web is such a brilliant, easy-to-grasp idea that it just took off. It became more famous than the complex, messy science it was supposed to represent.
So what does this whole debate really teach us? I think it's an amazing lesson in how science actually works. It's not this clean, straight line to an answer. It's messy, it's full of debate and passion. It shows us that awesome metaphors can be great for explaining things, but they can also oversimplify the truth. And it's a reminder for all of us, scientists included, that it's so easy to fall in love with a good story, even if the facts are a bit more complicated. All right, so after all that, what the heck is the forest actually saying? Are we looking at a real underground internet, or is this whole thing just a beautiful story? Well, the truth is it's not a simple yes or no. The science isn't saying that fungi are silent, not at all. It's saying the language is probably a lot more complex, and maybe a little less romantic than we first thought. Those electrical spikes, they're real. The networks, totally real. The debate is all about what it means. The forest is saying something. It just might be less about holding hands and more about complex trades, fierce competition, and a constant struggle for survival that we are only just starting to wrap our heads around.
You know, the science is still unfolding right now, and that's the exciting part. This whole debate is actually a really good thing for science. It pushes us to look deeper, to question our assumptions. The world under our feet is still so mysterious. So the real question isn't just what the forest is saying, it's are we listening carefully enough?